Buying battery energy storage systems is anything but straightforward. Prices shift rapidly, warranties differ significantly, and integration risks can make or break your project economics. As the European BESS market grows in both scale and complexity, making the right purchasing decisions has never been more critical. So, in today's session, we'll explore some of the key questions shaping today's BESS procurement strategies. We'll break down the fundamentals, evaluate cost competitiveness, assess supplier and product reliability, and endeavor to decode warranties and understand their impact on long-term operational performance. We'll be joined by a star-studded lineup of speakers who will strive to give you the clarity needed to make the right purchasing decisions, avoid hidden pitfalls, and secure lasting value in a rapidly moving and complex market. Hello and welcome to the fourth and final day of our PV Magazine Week Europe event. My name is Maria Maisch. I am Energy Storage News Director at PV Magazine and ESS News, and it is my pleasure to be your moderator in today's session. So, probably the most natural place to start with when talking about procurement is pricing. It's no secret that BESS prices have been on a downward trajectory for some time already, but the next metal crunch could be just around the corner. To dive deeper into the data and to explore the latest price dynamics, it is my great pleasure to welcome our first speaker of the day, Edward Rackley, Head of Energy Storage at London-based commodities market analysis and consulting firm CRU. Ed, it's a pleasure to have you here. Thank you for joining us.
Yeah, thank you, Maria. Thanks for the invitation.
Yeah, thank you.
Yeah.
And without further ado, the floor is yours.
No worries. Thank you so much. Well, good morning, everyone. Yes, I'm Dr. Edward Rackley from CRU. I cover the energy storage market predominantly at CRU, but we're a market intelligence company that cover the battery supply chain from raw materials to end of life. In our battery materials team, we focus on techno-economic principles, including cost modeling, bottom-up cost modeling, I'm gonna state, and technology forecasting. During this presentation, I will cover why LFP has become the chemistry to beat in storage and the reasons why it remains the chemistry to beat in storage, key supply chain drivers that you should be aware of as procurers, and what European domestic manufacturing needs to do to compete with Asian producers. I think when we've been looking at the battery market across the last 15 years or so, I think one of the major points that's always come up has been raw materials, as Maria has mentioned. We've gone through some significant changes in how raw materials are kind of transacted between manufacturers, vertical integration between for tier ones in the upstream down to the downstream. But one of the key things we've seen is a significant fall in materials prices due to material surpluses up in the upstream after the kind of lithium supply deficit at the end of 2022. So the key takeaway from this slide is to think about is that materials mattered effectively for battery storage, but we're at a point where in a supply surplus where we're starting to get to the point where cell makers are now thinking about how do you innovate past materials, and that's thinking more about manufacturing optimization and also technological improvements, some of which I will discuss in later slides. Just a quick background for anyone who's just entering the market or wanting to know more. Currently, the battery energy storage market is dominated by a chemistry called lithium iron phosphate, LFP. The large majority of LFP is produced in China, and from what we're seeing in terms of the supply chain in that midstream, I would call it, so midstream in this case being the devices that go into these 20-foot containers that you will likely procure for your projects, we're seeing a significant amount of production in China at the moment. So we're expecting this year, so far this year, China's produced 450 gigawatt hours worth of LFP cells for the ESS market. And just to give you an idea of what our view will be for global demand, we're expecting close to just over 300 gigawatt hours of installations this year. So we're currently in a significant oversupply for the market. Why this matters for you guys, for procurers, is that the Effectively, because the Chinese domestic market is extremely fierce, with a lot of cell producers, a lot of storage makers, and lots of integrated solutions coming into the market. There's a lot of competition in terms of pricing, and effectively a huge impetus for Chinese producers to export their systems overseas, which is obviously something that we're seeing in Europe is one of the largest markets moving forward for these producers. But hopefully that gives you a little bit of a background in terms of some of the reasons that we're seeing price reductions at the moment in the market is because of that fierce competition we're seeing on the other side of the world. So just a quick discussion on lithium iron phosphate. So lithium iron phosphate LFP is a chemistry that's been around since the mid 90s, but is kind of, I guess, hit vogue in the energy storage market in the last 5 years or so, kind of displacing nickel-rich chemistries. So the question I've posed here is, how does LFP continue to stay ahead in storage? The TLDR and the quick answer would be that pricing and technology improvements have really helped, but it's also a significant kind of change from producers thinking more about we've scaled materials and gone through that cost reduction era for battery storage, and now we're looking at other ways to kind of innovate along the supply chain. So these are three examples of how LFP has stayed ahead of other competitors like sodium-ion or even flow batteries. So we're seeing in the past 18 months or so, we've seen tier one producers look to add new chemical dopants to their battery cells. This helps increase the cycle life of the cells that are being offered and the systems being offered that you'd likely procure. And effectively for asset owners, that's really good because it means that your system should last longer. You should be able to transact more energy and transact and sell more energy predominantly. In the midstream, pushing further along to the device level, we've seen significant increases in cell capacity. Um, just to give you an idea of the scale of this so far, 314 amp hours was the market kind of incumbent last year, and we've seen significant changes in cell manufacturing and increases up to over 1,000 amp hours in the past year or so. Just as an aside, and just to make sure this is clear, the 314 amp hour cells that are going into 20-foot containers will likely give you a container energy of 5 megawatt hours. So that's likely what is being installed or you'll likely be procuring at the moment in Europe. We're expecting that to rise to 6 megawatt hours next year, predominantly from that shift in cell capacities, probably to 600 amp hour cells. It's not always the easiest thing to think about, though, is that when you're thinking about procuring, the other thing you're thinking about is logistics as well, and that's something where we were in the past 2 years. We've been looking at kind of where does LFP reach its edges predominantly, and I think one of the key topics that have come up in discussion, especially for us in the past probably 10 months or so, has been how do you keep optimizing around these 20-foot containers and the boxes that you're likely procuring for these projects? And one of the major things has been weight predominantly. So from our analysis of container weights, we're starting to see an edge being built for these LFP systems, especially for these 20-foot 5 megawatt hour containers and 6 megawatt hour containers. We're starting to reach trucking limits for or logistical limits for different products, especially in the West. I think that's something that's going to come up and something that the manufacturers have been trying to engineer around is that if you've got 50 ton weight limits for your storage units being moved by road, and obviously Europe is predominantly relatively landlocked in terms of sets of countries in that band. There had to be a breaking point where either you'd move to more modular systems, something you'll see from some tier ones like BYD, or we're looking at stacked containers, which is something that CATL and a few other producers in China have also looked at in the last announced in the last 6 months or so. So that's something very interesting. With that, kind of gives you the idea of how LFP has stayed ahead. Is that you've had chemical innovation, device level innovation in terms of packing, and also the size of the cells themselves. And we'll talk a little about manufacturing cost in the upcoming slide. And then thinking about how you manufacture for your application and the logistical challenges moving forward. So from our analysis, and obviously we get a lot of questions from clients talking about sodium ion and where we believe sodium ion will enter the market. At the moment, we're seeing a kind of a balance between raw materials price increases. We expect some in the short term, but that's predominantly due to some mine closures at the moment, especially in the lithium supply chain. But what we expect is that those technological improvements that I previously mentioned for LFP will keep it ahead, especially at the cell level. And we expect manufacturing costs for cells to be close to be $40 per kilowatt hour, and that will probably equate for a system level like range of probably between $60 to $80 per kilowatt hour for systems, and probably an EPC quotations of close to $120 per kilowatt hour moving forward, especially in the medium term. But with sodium-ion, NFPP is probably in our view, is the sodium-ion kind of blend of choice, a polyanionic compound. Its cycle life is very, very similar to LFP, and its energy density is pretty close. And we believe those are two metrics that will kind of bring it forward in terms of its competition with LFP moving into the medium term. On the right-hand side is just an example of how we expect those increases in cell capacities to kind of reduce the manufacturing cost. Effectively, think about it like this: is the dollars per kilowatt hour is the metric that matters in this term. So you're effectively capturing more kilowatt hours per cell that you produce with large capacity cells. And I think that's a key point that is worth knowing when you're thinking about procurement and thinking about I think effectively the interior of the containers and the systems you're looking to procure. So we've talked a lot about raw materials, and then we've talked a lot about technological improvements. Now think about manufacturing. LFP cell costs, I've described them as very cheap, and you've seen a forecast in the previous slide that would show that we're getting closer to $40 per kilowatt hour at the manufacturing cost level, especially in China. But the challenge here is it's a blend of both best-in-class materials, high scale, and a combination of low energy costs, high automation, and reduced land costs to heavily reduce those manufacturing costs. And that's something where European countries and Europe in general has a lot to learn on that side, and why we're seeing a lot of expansions in Eastern European countries like Hungary and Poland, and obviously Spain for a view on the energy and the kind of land cost view going forward. On this slide, we've shown effectively a route for cost competitive for European domestic manufacturing. And as I'd mentioned before, like we're talking about gigafactories, not of the tens of gigawatt hours, but talking three figures, 100 gigawatt hours plus, a huge reduction in the amount of workers per gigawatt hour, and that's hugely based on the automation kind of side of things, where a lot of Chinese tier one and best-in-class gigafactories are operating at those kind of worker counts. An incredible increase in yields. This is one of the hardest things to do for gigafactory manufacturing. Obviously, the losses compound along each stage of the production process. You've got improvements in the cathode and the chemicals, similar to what I discussed earlier. And then you're thinking also about that cell capacity improvement and how that reduces your manufacturing cost over time. But I think the key takeaway and the view on this side is to think about how Europe can move forward, and that's thinking about automation, new next generation technology, and those improvements moving forward. So just to sum up the key takeaways for the discussion, our view is that LFP will remain the lowest cost battery storage chemistry this decade, as those technology costs, chemical, cell, and system will offset some rising near-term material price rises. Industry oversupply, especially in the midstream, will persist, especially into that medium term, and we expect that will keep ESS prices low, which is great for procurers looking to source battery storage for their projects. But and then the last thing is that Europe will need to scale predominantly in automation and yields, and look to next generation chemistries to kind of compete at a cost level globally. Thank you so much for listening. And if you've got any questions, happy to chat, or happy to talk about it a bit later in the panel too.
Thanks, Ed, for this wonderful, informative presentation. What is, I think, also one of my key takeaways and very interesting to see is that like 10 years from now, the LFP price curves remains relatively stable, right? And then at some point they even meet with sodium-ion, so in 2035. Do you think that we can also expect some bigger changes in terms of LFP prices than the ones you just showed? For example, last week we reported about the latest measures that the Chinese Ministry of Industry was calling for, and they are trying to curb this irrational competition in the ESS space, right? This is the race to the bottom pricing that we are seeing, and the reports of recent tenders, how low the prices have got. How significant is this policy move, for example, as it came only like last week? Could it signal a potential rise in the prices next year, for example, already? Does it reset a moment for global ESS economics? And maybe also, is that positive news for alternative technologies?
Of course. Well, there's a lot to unpick there, but I'll go first for the Chinese kind of policy discussion first. I think one of the challenges with the Chinese policy kind of view and kind of the MIIT to the industry asking the MIT to see if they can curb irrational kind of production expansion is that it will take time for any of these measures to effectively bed in for the manufacturers themselves. And I think one of the key things that I did mention earlier on was that the production levels at the moment, like we've seen double the amount of cells required against global demand for this year, which means that you have to work through a lot of inventory before those kind of measures will take place. So I think if that is going to happen, it'll probably more likely be 2027, maybe H2, before we'll see any significant pressure there. I do think it does offer an interesting kind of point in terms of the geopolitics. If you're looking for alternative technologies and they aren't so China centric, they likely will gain some traction in that time frame. I think the price rises will be balanced with the technology improvements, and I think one of the major things we've seen, and also actually I'll go back one step. It's something with the kind of production capacity increases. We've seen something very similar in solar PV in the last 3 or 4 years. There's a kind of an overcapacity and then a crash in terms of the pricing and some manufacturers being going into bankruptcy. I think that's something that the Chinese government and producers for storage are looking to avoid. But it is a challenge, and I think it will take time.
Yeah, absolutely. It is a scenario, similarly evolving. Maybe we are a couple of years behind in the ESS space, right? But there is certainly this race to the bottom pricing that we are seeing. And you also said that we are looking at midterm oversupply, right? What can we expect? How can we expect supply and demand balance to evolve beyond this midterm?
I think beyond the midterm at the minute, it's we're expecting a lot of demand to come from like more from like the global south as well as Europe going forward, and we think that supply and like production now is almost too highly scaled for what demand is currently. But in that kind of 2030 term, we're expecting that production capacity to be more than not more than ample, but like it should be ample to cover the demand going forward, even from like I guess in new demand vectors such as data centers. But I think that's the kind of inflection point almost, is that it's that initial point where the production capacity is probably too large for what we're seeing at the moment. But it should hopefully balance out into that term, 2030 term.
2030. So that there is no oversupply beyond 2030, technically, right?
Well, I think the measures will probably take the measures going forward will likely curb like a larger kind of production capacity growth. I think the other thing as well is that we've talked about, and you said the race to the bottom for prices, they'll largely lead to a lot of market consolidation. And I think that's the challenge, is that if you've got best-in-class manufacturers and you've got tier 3 manufacturers, for example, that potentially exit the market in that time frame, the best-in-class manufacturers may not want to buy those or procure those other manufacturing facilities that are available because they're not up to their specifications, and they will likely be mothballed as well.
Yeah, because I know from my interviews with maybe best the tier 1, let's say, suppliers, that they actually say that there is no overcapacity, that they are producing at full capacity, also shipping at full capacity, and they see no indication of oversupply. If you would ask some of these market players,
I guess
would
in
you agree
their
on that?
Yeah, I think for those market players, I think they'll be relatively safe because they will continue that technological evolution. It keeps them competitive. They've got large order books for exports going forward. But even with the tier ones, from what we've seen, margins have fallen year on year. At least I think between H1 24 and H1 2025. I think they fell on average probably about 4% between the tier one manufacturers. So it's not that they're not they are relatively immune, but they're still seeing some pressure there on their on their orders going forward.
Yeah. So yeah, thin margins, something that we hear a lot, particularly in the solar space, but obviously hitting best players now. Many thanks, Ed, for this informative presentation and input. And we will now move swiftly to the next segment of today's program. And this is our panel on supplier selection and technology considerations. Ed from CRU will be staying with us for this discussion. And joining him on the panel, it is my great pleasure to welcome Arthur Clare, Head of Technology at Sinovoltaics, and Stefano Alberti, Vice President Technology EMEA and Country Manager South Europe at Hyperstrong. Gentlemen, thank you for being here and for joining us today.
Thank you.
Thank you. Good morning, good afternoon.
Good morning, good afternoon. Yes. Okay, Arthur, I would like to involve you here also to continue this talk on prices. Sinovoltaics offers services including quality insurance, inspections, factory audits, ESG reports, traceability audits. So from your perspective, what we can say, it is natural for a buyer to be tempted by an affordable price. But does a lower price naturally indicate lower quality?
Well, it's always more complicated than the low price, as you can imagine, because of course one buyer needs to understand what is behind the price in dollar per kilowatt hour. Of course, what kind of solution is it, but also what kind of warranty for the energy storage. Also, there are different.
Hello? Arthur?
Yeah, sorry, I got
lost you for a second.
It's fine now. Can you hear me well?
Yeah, we can hear you well.
Sorry,
yes.
but
no problem.
Yeah, I was saying it's way beyond the low dollar per kilowatt hour. And by the way, Ed, great presentation. And I was saying, yes, that of course the warranties associated with the energy storage systems that you want to buy are extremely key. And also, I will add that we can definitely see by visiting more than 350 different factories that of course you may have different quality based on the price that you're willing to pay, and of course depending on the T and C's of the terms and conditions of your contract. So, for example, if you want to have the cheapest price ever, of course, you may have sometimes we can see this, unfortunately, you may have no factory testing being done, or at least the bare minimum, and everything is being shipped to you on site. So, meaning that in case there is any issue being found on site, that becomes obviously way more complicated to prove it. But I would be actually interested to get Stefano's feedback about this.
We will involve Stefano in a second. So one question maybe to ask is factory testing done, for example, for the buyers when they talk to a procurer, to a supplier they're actually not familiar with. So Stefano, hello to you. I would like to bring you into this price discussion, price versus quality, or together with quality, we hope. So Hyperstrong is one of the leading BESS integrators in China, among top 5, and as of recently also making big moves in Europe. We saw the news, 1.6 gigawatt hour BESS project in Germany for LEAG. So from your perspective, maybe vice versa, does high price necessarily means good quality?
Okay, well, talking about prices for the technologies like me is always a little bit difficult, but no, seriously. In my opinion, people have to look at the price versus quality ratio more than price itself, because the price itself is a little bit misleading. My colleague said before very well that price is due to many things. It's also due to the way you process your product, the way you make it, the way you test it, the way you calibrate it, the way you certify it. So if you don't want to have bad surprises on the site, all these things have to be done before that. And this is something that is a hidden point. People don't see this. Sometimes when you buy something, you don't know exactly what stays behind because you don't know all the details. And this is what is creating in the public perceptions the concept of expensive thing. No, they're not expensive. They are higher quality. They have been tested differently. For example, in Hyperstrong, we boast to have an internal laboratory where the certifying body tooth comes to certify things also for the others. Now, this costs money. Having such a laboratory inside the company costs money, costs a lot of money. So it's difficult to realize this for the people. Second thing, I listened to what Edward said about the growing cell capacity in the next years. I really like that. Another thing, if I can add, is trying to increase the energy density. I mean, having a certain amount of capacity in smaller volumes. And this is extremely important for Europe, because in Europe, the land costs a fortune. We know that very well. We don't have deserts to fill with batteries, unfortunately. So it's very important. But this costs money. If you want to have a kilowatt hours that is in a smaller volume, you need to pay more. But then you save money when you store the things on the lands. So it's quite complex thing. So it has many parameters, in my opinion.
Definitely. And Ed, you mentioned in your presentation also that this higher energy density, larger cells, they don't necessarily reduce the cost on the system level. So this the cost reduction doesn't come from there. But do latest generation products nonetheless offer lower overall system cost?
Yeah, I think there's a balance with that. I think the you probably will be quoted for higher for these kind of higher energy density, highly energy dense systems like these 6 megawatt hour systems going forward. But I think one of the balances of that is the cells going into that will be a higher quality in terms of cycle life as well. And I think it's also, as an asset owner and a procurer, I think the balance is also how much energy you transact in that lifetime. And then that links back to the warranties you're available, whether these warranties become more flexible over time as well, in terms of what kind of revenue and return you'll get from your investment.
Yes, and Arthur, these are clearly very crucial technological improvements when it comes to energy density, going to bigger cells, but the newer technology, latest products are naturally less proven in the field. How does these changes impact overall quality and reliability?
Well, that's a very good question. Well, what we see now for sure is that the manufacturers, they have more experience with lithium-ion technologies than before. We can see for some players it's a second, third, or actually even more generation of battery cells. So there are more experience from past projects, past bad experiences as well, to be honest. So they are building on this. Still, I think there is an information asymmetry between most of the buyers of energy storage systems today and the manufacturers, in terms of asymmetry of information related to about the warranties, as I mentioned, about the kind of tests being done. Just to give you one example, I was in China 2 months ago to visit some of the tier 1 there, and it was really funny because one of the strongest challenges we see at Sinovoltaics is to be able to be at the factories for all the containers FAT. So by FAT, this is a factory acceptance testing. This is the final test being done at the factory. And many clients from Europe, they just trust their contract. Sometimes their contract is either not mentioning at all FAT, or they're just being vague. And so I was challenging the manufacturers about it. And it was funny because everyone was telling me that for overseas clients, so saying basically out of China, they are providing capacity tests, they are providing factory acceptance testing on each container upon request. So it means that if the client asks for it, they can start to negotiate it. I guess, as Stefano mentioned, it will have a slight impact on prices. But as you can imagine, it's much better to identify issues before shipment when it arrived at your site in Europe or Africa or the rest of the world.
Stefano is nodding. I can see that.
Yeah. What Arthur says is very, very wise. If I was an investor, these things I would check these things immediately. And when the supplier starts to say these things, then wow, I will try to look somebody else. No, I mean, again, this is why I'm seriously saying, please do not look at the price. Look at the price versus quality ratio, please, because these things change completely the mindset of the people. For example, when we talk about FAT or SAT or certifications, all these kind of things, they have to be there. They have to be there. How can I invest millions of euros on a project that should last for 20, maybe more, even more years, thinking that I have to hope that things are working? No way. But even in my day-by-day life, when I buy the fridge for my house, I check these things. So why should I check this for millions of euros investments?
Yeah,
this is a strange way of saying this.
Yeah, definitely. Definitely a very good point. And Stefano, maybe from your perspective, you can tell us something. For example, how attractive are the latest generation products that we talked about for buyers in Europe? Do you see some market specific preferences at this point? For example, DC versus AC blocks. Also, are customers after just core only, or they also want EPC wrap? If you could give us some insight on customer preferences here in Europe.
It's a great question. I thank you for this, actually. Yes, people do prefer something. They prefer not to have hidden costs once they are on site. It means that when the goods arrives at the site, it should be as ready as possible to be connected. This means that, for example, we clearly see a trend in the AC solution. When I see AC solution, I mean containers with the integrated inverters inside. Because if you do that, and then you have a container that is already in AC, then you know that you only need the local medium voltage transformer and then a switchgear to go to the medium voltage. And this saves money. On top of this means that also the inverter is from the same manufacturer, the system integrators, instead of having different manufacturers, which is also an extra interesting, let's say, peace of mind for the investor. So yes, we see this. And about the EPC, yes, we also see that people start to ask for a full EPC plant. It means that they not only looking for the supplying of the goods, but also for the supplying of the people who are making the civil works, the connections, everything done until the agreed. And they are willing to pay more, but because they do that to avoid problems afterwards. So yes, there is this trend clearly.
Okay. And Ed, so from your perspective, for example, AC versus DC blocks and when purchasing a system, what are the main considerations that should guide a buyer's choice? Stefano is obviously highlighting AC blocks. Would you agree on that? And what other things should be considered? So pros and cons a bit.
I think from my side of things, it's just working out if there's any technical differences between the AC and DC block going forward. I think Stefano did mention like the other connecting parts and the transformers and medium voltage switch gears. Obviously, transformers is going to be a hot topic, I think, going forward. We have some shortages coming forward in grain-orientated electrical steel, which could make lead time for some of these components could be longer. I think if I was procuring, and what Stefano had also talked about being if you're the manufacturer goes end to end, I think we're going to see more integrated products, whether AC or DC, to be honest, because I think it's a lot easier for an asset owner to be like, well, if I have a fault or I need to discuss a warranty, you pick up the phone to your one supplier instead of looking at 10 different component suppliers and trying to deconvolute that. I think there's a balance of like cognitive load for those kind of companies as well.
And Arthur, what is your take on this? Also, Stefano mentioned, so how common is the practice of sourcing BESS equipment from various providers? And actually, what are the pros and cons of such strategies?
So we see multiple cases. Sometimes, of course, you just buy everything from the same player. So even both transformer, AC side and DC side. Some solutions they provide, they will buy DC side from China usually, and AC side from Europe, for example. And even more cases, they buy like an AC solution, but the batteries are going to be delivered on site straight from China. So you have different options, I would say, and I fully agree with Ed that the main challenge is about the warranty. There may be other technical challenges about the site integration, but to be frank, I'm not the best expert about it. Yeah, for me, what's usually do that, to be frank, people contact us when they have issues. So and of course, when you have different suppliers, when you have a claim management to fight for, it's becoming more complicated if you have different suppliers.
And I think also worth mentioning is the risk of too many interfaces, right, Stefano?
Yes, this is one of the key things, and this is why people try to talk to us as system integrators, asking to have everything included. And if I may say something more, I will suggest to the investor not only this, but also please double check whether your system integrator is also located on the territory. Whether they have people here, whether they have the engineers on the territory, whether they can make O&M here instead of being left alone afterwards. Because in my opinion, the sales process is not just selling the system, it's selling the system and going up to the end of a lifetime. So this is very important. And is also part of the costs. We invest a lot of money for having engineers here in Europe. We have a centralized office in Germany, for example, for that. So it's very important. And this is related to this thing. So one interface, one team, one solution. This is our strategy, let's say.
Yes. And for example, so paper warranties are of little value if the OEM doesn't survive, right? So from the buyer's perspective, how can they identify reliable, long-term technology providers? Arthur, can we hear your take on this?
Yeah. Well, first of all, I would say that it's not a direct answer to this question, but what Stefano mentioned about the support, asking for credentials, local support across Europe, what is guaranteed response time, for example, is really key, because you don't want to have Chinese engineers coming to Europe every time that you won't be able to really exchange with. And also in terms of local project references is really important. And local certification, because what you want to avoid is to be the first project where the supplier will have to adapt to the local grid code. So I think it's key. And also to challenge them in terms of quality, like what kind of tests are you doing at the factory? And like just threaten them to say, oh, we'll use some third party to be there, see how they react, because again, like you are investing millions of euros, millions of dollars into it. So you should be able to to have visibility on the kind of tests being performed at the factory and during the site commissioning. And also one more key point, and I think that the next presentation will talk slowly about it, but access to what kind of data can you have access to? Because, for example, we had the case actually last week for FAT, like the manufacturers, they refused to share data. They shared data for the FAT. It was just some Excel sheet with pass and fail. And the idea was to get kind of the raw data from the BMS to be able to run a really forward analysis. But in that case, of course, we were not. And what everyone comes back to is what is written in the contract. And that's why it's really important that you discuss and that you clarify everything in the contract.
Yeah, fair point, definitely. So Ed, we are now looking at how to choose a supplier. We want to have a reliable supplier. We heard already some very key points on this. In the BESS space, so some suppliers are relatively new to the sector, but they are already well established, for example, in the solar industry. Multiple manufacturers, JA Solar, Longitudina, Jinko. So how does their track record in the solar industry influence perception of their quality in the BESS space?
I think it's a really good question. I think they kind of rise with more integrated products from like the renewable generator to the BESS is something that we're seeing moving forward. Obviously, you mentioned solar. I think for us, when we're looking at like advising clients in any way for like procurement, one of the things we've always looked at is almost like what we describe as a project gateway methodology. So you're thinking about with these kind of new offerings coming to the market from those particular producers, you're kind of reviewing where are they sourcing their cells from if they're not making them themselves? Like, are those going to be tier 1 or tier 2 like reputable manufacturers? Obviously, these are things you can ask, especially under NDA as well with your supplier. And then you've also got to think about have they manufactured at scale before? That's very, very important. I think that's something that we seem to a lot of clients or procurers don't really think about is like, do they have a good track record in their field of choice, for example? And then you're also thinking about what kind of project experience have they had before as well in terms of setting up projects. I think Arthur mentioned a great point about that, which is like if you're the first project in a region, it can be very, very interesting when you start trying to work out how you get through regulations and whether you've got an area which is kind of receptive to renewable kind of technology being installed. So I think for me, it's kind of the balance of manufacturing previous experience, even it's in a similar kind of assembly based industry for solar in this case. Thinking about supply deals and their ability to scale them, who their suppliers are, and then finally thinking about like kind of what things you need to think about for your like project itself as well, and what they can offer on that side.
Arthur, so another key differentiator. Are you with us, Arthur?
Yeah, I'm here.
We lost you for a second. Sorry. Is also vertical integration, right?
Yes.
How important is this for when we talk about ensuring quality and reliability of the end product?
It's really, really important. Like Edward just mentioned that, yeah, understanding where the cells are coming from is really key. I will add just one point is that let's say you are buying from a tier 1 BSS player. One point to actually clarify is which factory are they going to use to manufacture your project? Because what we can see more and more is that like 2 weeks before the manufacturing starts, our clients, they realize that they were buying from factory A, from brand A, but actually the BSS are going to be manufactured at some random factories that they had never heard of. And it's really, really important point. And as you can imagine, if you start to have issues, it can go only downstream, I would say, especially as you can imagine it. And that's what we see both in BSS and also in the PV space. you use what we call OEM factories, so third-party factories, it's not the same staff being used to it. Those guys are usually being used as kind of extra capacity for the tier one players, so you cannot kind of expect the same quality. And definitely not all factories are equal. So clarifying which factory you're using, and again, put it in the contract maybe is the right choice.
Yeah, a very good point. Practical advice. Stefano, we talked also now about this, say, issues appearing on the cell level, but actually the biggest issue arise on the integration front. They dominated the BESS manufacturing defects. What are the key quality shortcomings buyers should be watching out for in this aspect?
There are many parameters that should be considered. The efficiency, of course. So how we are able to keep the energy that we get and then to release. It's called, if you want, RTE, the round trip efficiency. That is a clear indicator of the goodness of your system. And this parameter depends on a chain of other efficiency. The efficiency of the transformer, the efficiency of the inverters, the efficiency of the battery, how much they can store and they can release. And all these aspects are key in this business. And the way we, for example, in Hyperstrong control this is optimizing, for example, the thermal control, the thermal loads. We know that in electrical engineering that either we produce electric energy or we produce thermal energy. We don't want thermal energy, we want electricity. So if we are able to control this in a better way, then we get a higher efficiency. And I like what Arthur said about, for example, the BMS, the way we control the things. We do in-house. Everything is in-house. This is why we are a system integrator. So I would seriously suggest to the investors, please look at all the chain of the goods that are related to the BESS. Try to compare when you can apples with apples in order to make sure that then the final efficiency is higher. And this is also influencing the lifetime. Because if the efficiency is higher, the system is less stressed than others, and because of that, its lifetime will be longer. And then you can stay for maybe 20 years, maybe even more. This is our philosophy. This should be the strategy that the investor should follow.
And add anything to add to this? Okay, we discussed now. We're going now into a bit more product reliability, but also we discussed supplier reliability. And when we go to trade shows, there are quite a few not exactly household names that we are seeing. And if a potential buyer would be interested in procuring from such companies, is there any type of question? So what is the first question to ask, for example, or something that definitely we shouldn't miss?
I think for me, one of the first questions I ask is that how long have they actually been manufacturing in the market? I think one of the challenges is you'll see mostly publicly traded companies, and then there'll be like new companies that you won't be aware of coming into the market, and it's just trying to know like what their like manufacturing acumen is and that kind of background. And I think one of the challenges for us is kind of looking at that like new tech or like new cell or higher cell capacity kind of view. Is like, are they offering those, or are they offering the 280 amp hour cells that we saw in 2023? I think that's the challenge. Is do they have a clear roadmap as to how they compete in the market against the I guess in the established players? Just a quick question, Maria. Just if this is all right, I wanted to ask Arthur a question on this.
Yes, sure.
Arthur, more on so looking at these like bigger cell capacities we've seen. So we've seen 314 amp hours, and now we're seeing some cells going over 1,000 amp hours. Do you see any Voltaic see any issues with like thermal management or any like cycle life issues? Because a lot of these 1,000 amp hour cells seem to be tuned to do 4-hour durations, and I'm concerned that the bigger cells get, the harder it is to kind of control the temperature. I'm sure Stefano has also some opinions on that too.
Yeah, exactly. It's a very good point. Like the challenge with the bigger cells is obviously the thermal management. Because as you can imagine, if your cell is like this, like those different extreme points are usually the most harder to cool, or and so it may trigger some issues as part of the both at the battery cell but also the battery pack integration. Because with the battery pack integration, you may have the sensor temperature is located at one side, but you will have less information, I would say, about the other extreme of the battery cell. So that's one key point to keep in mind. But about this, and it's coming back to what we all said before, the certifications for such cells are really key. And also being able to run some degradation testing, some high temperature test is also quite critical. Again, if you want to invest millions, tens of millions of hundreds of millions of euros into one project, you want to make sure that the batteries will last 10, 15, 20 years instead of 5.
Can I add a comment here?
Absolutely.
It's very important what they say. Again, the thermal load is our number one enemy. Nowadays, basically, everybody is looking at the liquid cooling systems. That's not a new thing. What is new is the way you do it. Again, if you are going to check for the quality and the way a product is done, double check the way they cool it, the way they distribute the pipes inside the system, how many points of temperature measurement they have, how many probes, the kind of fluid, what they are using, what kind of flux they are using, what kind of alarms comes when the heating or the cooling is not as it should be. All these things have to be very well controlled because, again, the heat is something we don't like. So we need to produce electricity. This is the point.
Can you tell us, like, what is the standard? So what is the high quality liquid cooling? So with how many pipes, for example, just to have some sort of a feeling?
It depends the way the container is made, how many racks you have in the container, how many modules you have in the racks. It's a little bit difficult to say that, but for example, in our case, one of our latest products is the 10 foot, only 10 foot, 3.2 mega, which is, sorry if I make advertisement, but I think it's important.
It's an example, it's fine, totally.
This is a 3.2 megawatt hour system, 05C, it means 1.6 megawatts. Inside this container, we boast hundreds of probes located in all the main parts, in all the corners, up, down, left, right, all these probes, and are there pretty close to the back of the module, where the module is maintained cooled. And one of the key things is having not too thick modules, because in this case, from one plate to the other, there is a too much distance. So try to reduce it, and this means again increasing the energy density. So this is the technological way out. It's not so easy to do it. You need very high quality. Yes.
And I think we naturally also are going there already, but I wanted us also to cover how to read a product data sheet and warranty terms. So we discussed also supplier profiles that we are seeing, and maybe add when evaluating BESS products, what are the key pieces of information we should be looking for in the product data sheet? Stefano already mentioned round trip efficiency. What is also very important?
So you'll be looking at cycle life is a significant one. Obviously, that is very variable on your depth of discharge, and that's something you have to discuss with your supplier. I think also operating temperature range is very important. We've talked about thermal for the last 10 minutes. So I think those are two major ones from my side, and potentially also operating voltage as well.
Stefano, can you explain?
One thing, I like the story of cycling. Edward knows that we talked about this last week. One suggestion, please, to the investors. When you talk about number of cycles, okay, but please try to say to the designer what kind of cycle is going to be. Because to me, number of cycles is not so interesting. Sometimes it's more important to know what kind of cycles you are expecting in your financial model and your BESS. Then we are fine. But otherwise, only the number of cycles per day is a rough indication. Maybe it's not really the best. Otherwise, if we don't know that, we assume 0, 1, 0, 1. This is not really the best scenario.
But this is not what we see in the field, right?
Yeah, exactly. So in the interest of the investors, please try to be more specific. When you say, hey, this is my cycle, please make the estimation of the degradation and their lifetime. My suggestion.
Arthur, anything you would like to add to this?
Yes, I'd like to add one comment about the operating temperature. Because usually for BESS, the datasheet sometimes they try to stay a bit vague, because you have the operating temperature of the container, which is usually minus 25 to 50 degrees, I would say. You need to be extra careful, especially in the northern part of Europe, because in like Finland, for example, we had this case, like the temperatures can go actually below that. And what our clients had to do is to build some kind of insulation building around the BESS to make sure that the temperature of the BESS, that the operating temperature of the BESS was above minus 25, because otherwise the warranty would have been voided, which is, of course, what you want to avoid as an asset owner. So that's the first thing. But operating temperature, careful about the minus in terms of winter across Europe. And also ask as well for what's the cell operating temperature, because it's different from the BESS operating temperature, because of what we mentioned about the cooling system. Those temperatures will be of course different. Like operating a lithium-ion cell at minus 20 degrees, it's not going to work, for example.
Good luck. But do BESS products typically live up to the claims in the data sheets?
Usually you need to ask for additional data. And when we advise our clients into their procurement contract, we ask them to have the clear data sheet, detailed data sheet, not the one pager of the BESS, battery pack, and battery cell. Because the other point to be extremely careful about is the rated energy of the containers versus the usable energy. So I'll give you one example we have seen last month. We had a client buying 10 containers, 5 megawatt hour, so 50 megawatt hour project, rated energy, but you realize that in the warranty and also in the FAT checklist, actually, that the energy, the threshold energy was 4.7 megawatt hour. So you lose around 5-10% of usable energy, and this is the actual value. So in the end, 47 instead of 50 megawatt hour. It's the actual value that will be part of your warranty. And as you can imagine, the return on when you realize this now, the return on investment of the project is going to be much smaller. So you need to be super careful about it. And why is it different? Because the manufacturers, of course, they take some safety buffer to make sure that the battery cells operate at quite smoothly. Also, they will usually advise you as part of the warranty to use the BESS in some specific charge and discharge rates that we call the depth of discharge. And in the end, this is all impacting how much energy you can actually use. So I will be extremely careful about this point.
So that depth of discharge, 10% and 90%, or?
For example, it depends. Like it's kind of it could be 100 to 20, it could be 100 to 0. It depends how the BMS is built and is designed. But it's one point to be extremely careful about, because the real energy you can use is actually the usable energy written in the warranty performance as part of your contract.
So and warranties, are another piece of paper which is very important, particularly also for the lenders, right? And we have these commercial warranties, which are usually short term. They cover component defects at the beginning of the asset's life, but there are also performance warranties, very important piece of paper, which span up to 25 years and guarantee specific operational standards over that time. So Stefano, what are the key elements of a strong BESS performance warranty? What should buyers be looking for when reviewing them?
Again, if you talk about a performance warranty, then we as producers commit ourselves to guarantee certain minimum level of efficiency of energy injection and absorption, and we are supposed to test this on a regular basis. This is, in my opinion, one of the key things that the investor should look at. Whether the supplier is willing to do this, is willing to sign it, is willing to test it. The product itself usually is maybe 5 years, that can be extended to 10. Now, this is something that is standard. What is more important, in my opinion, is the so-called LTSA, the long-term service agreement. And related to this, you might have the performance warranty up to the lifetime. So then you know how your business model will work, because you are guaranteed in this respect about the amount of energy that is going to be delivered.
Arthur, can you share your take on this? Anything to add?
Well, I kind of anticipated the question with my previous answer. But yeah, what you need to be careful about in the performance warranty is that the conditions are quite precise, because you may have only like the most simplistic performance warranty is to say that the state of health will be, I don't know, 70% after X amount of cycles.
Yeah.
But actually you have a huge unclear area, because if it says that it should be 70%, 80% after 10,000 cycles, for example, if you reach 82% state of health after 8,000, you're still within the warranty. But even though the performance of the BSS is below what you expected. So you really need to be clear about the kind of conditions are written there. And it's, again, I think one point where there is a kind of a knowledge asymmetry between the BSS buyers and the manufacturers, because obviously they know how their BSS operates. And one additional point I'd like to add, maybe to finish on this answer, is that the issue kind of for the owner of the asset, when you have any claim management, is that every information is available for the manufacturer to prove if something was not, if one of the warranty conditions was not respected. So in the end, they will be able to void the warranty if they want, because they will have this huge amount of data that sometimes you don't have, because you have not put this clause as part of your contract. But it's really key that you have a clear monitoring solution, that you can store detailed data about the operation of your asset.
And Ed, can you also share a piece of advice on this? Also, how to compare these performance warranties? Is it actually difficult for buyers to compare them? Do they differ widely? And maybe also what the common pitfalls could be?
I think the key thing will be communicating with your suppliers about very much what Stefano had said about what kind of cycles you're actively looking for. I think one of the other things that that may kind of swing things over time will be whether there's any flexibility in that performance warranty in terms of what markets your energy that you transact could be going into. I think in the UK, as an example, ancillary market is extremely saturated, and it might be one of those things that your project goes for approval, you wanted to do ancillary, and then you want to sell into a different market going forward because that's too effectively, it's too competitive. And I think that might be something that comes forward, is whether you'll be able to have some flexible arrangement with the supplier, obviously within their like performance bounds, for example.
And that also means to design with flexibility in mind, because we never know. BESS is so versatile. Maybe new revenue streams will open up, right?
Of course.
Also an important one to take away. And as we wrap up, one question for all of you. Looking across technology, warranties, and supply reliability that we endeavored to cover here, what's one piece of advice that you would give buyers to avoid the biggest pitfalls in BESS procurement? So just a short way of summarizing our panel today. Ed, maybe you can start.
I think it's make sure you communicate your use case effectively. So that's cycle life or what cycles you're looking for.
Stefano?
Yeah, it's very important to have somebody beside you. I mean, if the company is there, on the territory, is there is anyone there you can talk to. We don't like to be just suppliers. We like to be consultants. We like to know what is the reason why they want to have a BESS, for what reason, what is the financial model. Then we can talk to each other and we can understand it better. This is a very important thing. And out of it, the investor understands who is the supplier. Is just a technological company, or is a company who knows also the market? This is an interesting indication, in my opinion.
Yeah, definitely. Arthur?
Yeah, so first of all, both Ed and Stefano's points are great. I would just add that I would say testing in a word, but in a way that to understand. But first of all, how the BESS got certified? How is it going to be tested at the factory? How is it going to be tested during site commissioning? And also what kind of test you should do to make sure that everything is going well during the 10, 20, 25 years of operation.
Yeah, absolutely. So Arthur Clare, head of technology at Voltaic, Stefano Dedici of Hyperstrong, Edward Rackley of CRU. Thank you, gentlemen, for being here with us. Thank you for your time and for sharing your expertise so generously.
Yeah, thanks all.
Thank you so much. Thank you. Bye-bye.
Thank you. All the best.
Thank you.
And in the next segment, we'll take a closer look at some of the common contract pitfalls that we highlighted just now in our panel, but we will try to understand them based on the hard data and their real world impact. Joining us on stage to share hands-on experience and insights drawn from gigawatts of projects in the field is Edward Mulloy, Senior Solutions Engineer at the Cure Battery Intelligence. Ed, welcome. Do we have Ed?
Hi, sorry. Yes.
Hi, Ed. It's a pleasure to have you with us.
Nice to
welcome,
be here.
and
Thank you for
the stage is yours.
Great, thank you. So, good morning, everyone. Thank you, Maria, for organizing today's event. Thank you for having me. Today, sorry, is it working? It is working. Today, I'm going to talk about buying BESS and highlighting how expensive it can be when that goes wrong, and then the challenges of comparing apples to apples when comparing different offers from different suppliers. So I'm going to walk you through 3 examples from customers we've worked with this year alone. The first one, how 2 letters in a test definition can result in you overpaying by $2 million on your capex. The second one, how 1 parameter change cuts the internal rate of return of your project by 1% and can delay the payback by a year. And the third one, how ambiguity in a clause can result in you losing huge amounts of your annual revenues and not having rights to any liquidated damages. And all of these examples are not technological failures, but issues with contract language. And it's a topic that I care about because I've sat on both sides of the table. So before working at Acure, I was at Northvolt developing their grid scale ESS product, and there I helped to write the contracts, the technical definitions, and the performance guarantees. Now I work at Acure, and Acure, for those that don't know, is the global leader in battery analytics. We've analyzed operational data from over 18 gigawatt hours of assets across the world at this point. And our platform helps asset owners avoid downtime, improve revenues, and operate more safely. And because we onboard so many systems, we review a lot of contracts from them. And what I've learned from my experience is, firstly, that the OEMs are very risk averse. They're the ones that design the product. They also write the baseline contract, and therefore they define where the risk is sitting. And because the industry fixates on dollars per kilowatt hour, the OEMs are incentivized to push the risk out of that number and instead put it into the contract. So yes, the price may look good, but you need to be aware of what liabilities you're inheriting that could reduce the saving that you see. So you need to understand technically the complexity of it and how the risk is therefore allocated. Sorry, I'm behind on my slides here. And this is where Acura is a very powerful partner. Every time we onboard a customer, we map their entire LTSA and warranty structure into our platform. And that means that we're continuously reviewing contracts from all of the major suppliers and integrators and across all major markets for the last few years. And we're not just looking at the contracts in isolation. We're also monitoring what happens after the contract is signed. So we review FATs, factory acceptance tests. We support during commissioning and site acceptance testing, and then through operations as well, from COD onwards to the end of life. So we see how real assets perform against the guarantees in those contracts. We see where the terms hold up and where they don't. And the combination of contractual insight plus the operational data we have gives us a very unmatched perspective. So now into the deep dives. The first one here, connecting champagne to batteries, starting with capacity tests. A capacity test is your yearly check to confirm that the asset still delivers the guaranteed amount of energy. That sounds quite simple, but the usable energy of a battery is extremely dependent and sensitive to how you charge and discharge it. And this is where CP, constant power, and CV, constant voltage, come in, and the champagne analogy. So if you were to charge at constant power, CP, that's like pouring a normal glass of champagne where the bubbles quickly rise, and then you stop early to avoid spilling, and you end up with a half glass of champagne. Alternatively, if you do a CP followed by CV, so constant power followed by constant voltage pour, that would be like slowing the pour as the bubbles reach the rim, and you keep adding champagne gently until the glass is full. So it's the same glass, same champagne, but I would rather have the second glass. And it's the same with batteries. And for a typical LFP 2-hour system, that difference can be roughly 5% of the energy, which means that if you have then in your test definition for your capacity test, if that allows a CV phase, but your operations don't, then you can end up with appear to have more energy on test day than in real life, to the tune of 5%. And if you have, say, a 200 megawatt hour system at $200 per kilowatt hour, that's $2 million in capex. So those two letters can really be material. Moving on to our next example, and this time on round trip efficiency. So we recently reviewed a procurement offers from a customer. They had several offers, and two of them were very similar. However, they differed a lot on the round trip efficiency. One supplier guaranteed 86 and the other one only guaranteed 81% efficiency. This is on the AC side. And you may think that that's a small difference, but it's not. In reality, if your use case is, for example, wholesale, so arbitrage, full cycling, if you did one cycle a day, every day for 20 years, putting numbers to that, the lower efficiency system would need to purchase roughly 45 gigawatt hours of extra energy throughout its lifetime to deliver that same service. And so when you model the cash flows for that, the higher efficiency case brings the payback forward by a year and improves the internal rate of return by 1%. So again, very non-trivial and absolutely decisive for your business case, especially in high energy applications. onto the third pitfall, so availability. And on the right here, you see a particularly ugly availability formula that we reviewed earlier this year. And this comes from a tier 1 supplier. And it has 25 variables. It's actually still ambiguous despite its complexity, and it requires manual calculations after every outage. And when we put a year's worth of data through this, depending on how you interpret the ambiguity, that exact same data set can produce availability results of 91 or 98% availability. So a 7% spread, which is really enormous. Again, to put some numbers to that, 7% of a year in days is 25 days. And in ERCOT in 2023, 50% of battery revenues were earned in just 13 days. So if you had 13 days, half of that. And if you had a 200 megawatt hour BESS with an outage throughout the whole of August of that same year in ERCOT, you would have lost $20 million. And you're never going to get liquidated damages to the tune of $20 million, but you could end up in a scenario where you've had severe revenue loss because of poor downtime, but your vendor interprets the same data set as being 98%, and therefore according to the guarantee. And so you would have no right to liquidated damages, or at least end up in a dispute about it, which is typically very challenging to resolve and not where you want to end up. And the good news is that there are simpler ways to define this. For this customer, we encourage the customer to push for the example you see on the right here, which is a one-line availability definition. It's ambiguous and aligns better with their operations. And in this case, the supplier accepted it. So this is the power of knowing what good looks like and pushing back when something is off or not industry standard. There are many more areas within the contract that hide risk and complexity and that are worth looking deeper in. I don't have time to go through all of those today, but briefly to rush through some of them. Data logging, very important to define how missing data is treated. Data ownership, also very important that you control and have access to your own data and can share it with whoever you choose to. There's a lot of value in your data. State of charge accuracy, something we see, and guarantees around the state of charge accuracy is something we see becoming more interesting for lots of our customers. Important to have them included in your contract, but without overly restrictive conditions. Maintenance timing, very important that you can align your maintenance around low revenue periods. Performance guarantees, huge topic. You want to have flexibility, you want to have it to match your duty cycle. Liquidated damages also gets complex quickly. You want it to reflect your use case to match the impact of the downtime or performance losses that you see. So all of these topics can materially shift risk between you and the supplier, and I haven't gone through all of them now, and this list is not exhaustive. And yeah, to summarize, so a good contract has clear definitions, it has competitive benchmarked values, and it aligns with your real world use case, and it gives you flexibility for future market or revenue changes. A bad contract, in contrast, even if the price is great, can quietly erode your returns throughout the lifetime of your project. And that's the main message for today, similar to, I think, what people have spoke about before, that the real cost of a battery goes far beyond the dollars per kilowatt hour price. It's also in the contract. And that's where we see a lot of buyers winning and losing. So if you want to make your next supplier agreement, make sure it's competitive, future-proof, and aligned with your operational goals, feel free to reach out to me or Cure. We can help you understand where the risk sits, how to reduce it, how to negotiate terms that protect your assets, revenue, all based on our benchmarking library. Thank you very much.
Thanks,
Happy
Ed.
to take questions.
And this was very insightful. Maybe I just include here one a question from the audience. So you say don't rely on quoted values of round trip efficiency. So what should buyers actually look at to assess a battery system's real efficiency?
If I did say don't rely on quoted values, I think that was a mistake. I think you have, at least in the procurement stage, you have to rely on the quoted values. Typically, they are conservative values, so you may see, or you should see, better performance in real life. But because they're the guaranteed ones in your contract, that's typically what you use to model your business case, because it's a guaranteed value. So I would suggest that you do use that unless you have access to a proper benchmarking library and you can see what the industry norms for that hardware is.
Okay, that's good that we clarified that. And maybe just one more, because I know Acure has a lot of experience also from the commissioning stages of the project in the field. And also one of the, so to say, one of the pitfalls that we partially discussed in the panel was also interoperability. So what are the most common challenges, and what should buyers be particularly aware of when they decide to go for various BESS equipment providers? Can you also give us a bit of input on that?
The most common challenges in commissioning, you mean?
Yes, but particularly when they procure their BESS equipment, so BMS, the system from different parties. So what are the challenges that you are seeing there when the projects are being commissioned, switched on in the field? Yes, what should they be aware of?
Sure.
Yeah?
So timing, I think, is everything in commissioning. If you took the QR code from what I shared at the end there, that takes you to a report, some research that we did this year that showed, I think 10% of sites that we've monitored were 7 months or more delayed. So commissioning delays are ubiquitous in all markets around the world. So anything that you can do to manage that risk and ideally reduce the likelihood of it is important. So then, this interoperability, I think often the more suppliers you have, the more people to manage, more communication needed, the more chance I would suggest for delays. I think also we see a common issue is that a lot of the crews doing the commissioning, it's often their first, maybe their second or third battery, but they're not experienced operators, and so having insights into which things to fix when and in what order certainly is beneficial too. So having an expert in the room, quote unquote, can certainly help manage those delays.
Absolutely. So you would technically even advise against going for such procurement strategies?
Yeah, I would think about the risk of delays, and if there's a benefit for going that way, make sure it outweighs the risk of potential delay increases. Yeah.
Okay. Thank you very much, Ed. Thanks for being here with us and for all your input. And it was a pleasure. And for our final program point of the day, tying everything together, we'll focus on the next and final phase, operating projects in the field and recuperating our investments. So we've made our technology decisions carefully. We calculated our business cases based on key parameters impacting project revenue. And now the system is running. It's time to recuperate the investment. That said, there is no better person to talk to than someone who is responsible for optimizing revenues. Guy Holding, head of sales at Inspired, is joining us next. Inspired is Vienna-based optimizer. Guy, it's a pleasure to have you with us. Can you hear us well?
Hi, thank you. Pleasure to be there with everyone today. It's good to see the debate already started on the impact of performance warranties. And what I'd like to do today is share a bit of information from the optimizer point of view as well. So what I actually want to talk about today is flexible performance warranties and their sort of impact on cross-market optimization. Before I jump into that, I just want to give you an overview of Inspired, so you understand we know what we're talking about. So we're currently optimizing over 2 gigawatts of BESS under management at the moment. Various dimensions, various configurations. Also, when you're taking into consideration the German market, various flexible connection agreements and grid restrictions as well. So very normally and frustrating from our side, the optimizer is usually thought about right at the last mile of a project, of course. But we are able to provide a lot of information, a lot of data, and a lot of knowledge at earlier stages of projects. So particularly from Inspired's point of view, we like to be brought in early stages because our role is to maximize our clients' revenues. So the optimizer really sits in the middle between the battery projects and the power markets. We're doing 8,000 plus optimization runs a day and over 3,000 trades per day in order to maximize this. And of course, performance warranties do have an impact on how optimization can be done. But to understand the problem fully, I think it's good if I quickly jump into how an asset is actually optimized on the market to give you a better understanding. And then that would make sense later on when we're talking about the impact of performance warranties and their impact on revenue capture, of course, as well. So standard cross-market optimization works this way. So day ahead, we're bidding in allocations into FCR and then again into AFRR capacity, of course. And then on the actual day, we're doing wholesale and AFRR energy arbitrage as well. So the role of ourselves is to provide the best trading performance on the short-term power markets, but we also there to find the smartest combinations and bidding strategies as well. And these run when the algorithms are, let's say, running its numbers, run into the millions of scenarios that we do. But to give you a better idea, what we take into consideration, if I can just change my slides. Yeah, so the data, what I want to show you today is actually from a real-life asset performing on the German market. We took a snapshot of a 24-hour period, just so you can see how a dispatch looks like in the real world for cross-market optimization. It's 10 megawatts, 20 megawatt hours. As you can see here, we bid in across FCR here, so very simple optimization at present. And then actually what we're doing is adding AFRR capacity to that. So you can start seeing it gets a little bit more complicated as we progress. So these are the allocations that I mentioned before that are taken the day before actual trading as well. And then what we're doing on the actual day is we are actually adding wholesales and AFRR energy arbitrage as well. What's important to note on this slide is there are quite a few positions during the day that actually net each other out. So you can see around about 8 o'clock, 9 o'clock, a couple of positions netting each other out quite a lot. And all this has quite an impact on how the dispatch that we send to the BESS actually looks like. And this is very important because both integrators and optimizers look at the problem from a different point of view, I would say. So taking into consideration the dispatch that I just mentioned to you here, we see how the optimizer and the integrator look at things. So the optimizer reality is on the left-hand side of the screen. You will see the dispatch profile, SOC profile on the bottom, much more gentle to what some integrators take into consideration. This was also mentioned on the panel of what is a definition of a cycle. Also C rate as well. So for this asset, it's 0.5 max, but you can probably see the C rate for this is 0.3, probably 0.2. So much more gentler on the asset than what the integrator assumes, because the integrator has to assume a full charge, full discharge, and full charge at the cycle. And this is why you see things like rest times in between cycles. But what we always recommend at Inspired is to bring us in early, I would say, because we're very happy to talk to the suppliers in depth. We do it quite a lot with regards to performance warranties and their impact as well. And we've been very successful, I have to say, in getting much more flexible performance warranties for our clients. To show you some of the impacts that this can have, sharing my screen here, some analysis that we've done internally. So the difference between having a 1 hour resting period and no resting period at all is up to 12% impact on revenue capture. You can also see the same for the average cycles per day, so 1.5, 2, and 2.5 can have or even 1.5 to 2 can have a plus 11% effect on revenue. SOC ranges as well. So if you have a 90%, so the buffers in place rather than a 100% SOC range, 7%. Round trip efficiency, we do not see so much of an impact, particularly when you take into consideration virtual cycling, for instance. But all these, let's say, parameters, if not discussed, evaluated, and negotiated correctly, can have quite a large impact on your project, of course. Sharing with you now how it all looks altogether. So the impact of warranty conditions on the revenues. So even small changes can make quite a large difference to revenue capture on the project over a lifetime. So even a 1% difference in round trip efficiency, usable SOC ranges from 95% to 100%, different cycles as well, and availability that was mentioned before. So if you add this all up together, it comes to around about 11.5%. Looking at that in hard numbers, which is what we all like. So for a 50 megawatt 2 hour system, it's about a 1.5 million year impact on revenue, giving you 15 million, let's say, additional revenue if negotiated correctly over a 10-year period of the project as well. So performance warranties, we prefer to be as flexible as possible, I would say. Doesn't mean that we're degrading the battery anymore. We're taking into consideration all parameters on the battery. And now what we're starting to see in performance warranties are things like, let's say, rolling average C rate example, which is perfect from an optimization point of view. So quick presentation today. One thing that I do want to emphasize is, when you're choosing your suppliers for the project, bring in the optimizer early, can provide a lot of value. Looking forward to engaging with you all. And yeah, if you have any questions, I'll be very happy to answer them. Thank you.
Thank you, Guy. Just checking if you can hear us for a couple of final questions. Can you hear us? I know we had technical challenges.
Yes, I can hear you.
Oh, perfect. Yes. We talked now about performance warranties. You showed a lot, and obviously, as an optimizer, but also it is in the interest of the asset owner. No one likes rigid warranties. As a wise person once said, we don't want to drive a Ferrari in the first gear. How difficult is to find a common ground between optimizers who aim to maximize revenues and integrators who aim for protecting the system? Is it a very challenging process? And are there some that are more open to it, to adapting, more flexible as compared to others?
Yeah, it's a good question. So we've seen performance warranties over the past 2 years become more and more flexible. Let's say if you were looking at a warranty 2 years ago, you would probably have, let's say, fixed daily cycle rates. Now we're seeing more of a yearly average, with daily averages of 2 over the year, but with the ability to go up to 3 or 4 cycles, which gives us the flexibility to cycle more when the market requires, i.e. in Germany during the PV peak in the summer, of course, as well. I think it's more about knowledge sharing and bringing all partners together at early stages of a project to have these discussions. So we spend a lot of our time talking to the suppliers so that they are able to better understand how an asset is actually optimized in the real world. And due to that, they have been a lot more accommodating, and also in some cases, you know, really took the bull by the horn and changed their performance warranties to be a lot more flexible for the clients as well.
Mm-hmm. Okay, yes, that's a fair point, and maybe not something that everyone has on their radar when procuring. But as you said, it's useful also to involve optimizers early on. And you also mentioned this 100% usable state of charge, which is relatively new, right? From your experience, do these warranties actually hold up under real-world operating conditions?
Yes, they do. So what we're seeing is based on, let's say, yearly average C rates, yearly average cycle rates, with 100%, let's say, SOC ranges, then you're getting various degradation curves and SOH levels, for example, which you can fix to your performance warranty as well. So it's all about having visibility on the project, how it is being optimized, and talking to all the key players in your project, not just before a COD day, but for the whole duration as well.
Mm-hmm. Yes, thanks, Guy. I think that's a great place to leave this for today. Thank you for joining us and for your valuable contribution. And with that, we are wrapping up our BESS procurement session. We hope you found it insightful, that you had the chance to draft or update your BESS buyer checklists, and that you took away some valuable messages and lessons for your projects. Once again, thank you to all our sponsors, our lead sponsor, Create Energy, platinum sponsors, Huasan Jinko Solar, Scholz Technologies Group, gold sponsors, Belectric, Intertech, CEA, and Stoibli. And yeah, stay with us because up and coming at 3 p.m. today is another session with a focus on BESS, but in the co-location settings. And we will be discussing some of the best practices in co-locating solar and BESS across Europe. This session will be moderated by my colleague Michael Fuss. My name is Maria Maisch, and you are watching PV Magazine Europe 2025.